The importance of cohort index date in Study Designer. For additional insight, read the book Riddles in Accountable Healthcare, available from Amazon in either paperback or Kindle. We studied in class hospitalization rates after achieving good or bad hemoglobin A1C. That is, we took a look at a cohort of patients who started off with a bad hemoglobin A1C and then ended up at day 180 to day 365 with a good hemoglobin A1C, and another cohort who ended up with a bad hemoglobin A1C. We then looked from the moment of achieving either a good or bad result, and we followed those patients forward for a year's time to look at hospitalization rates. And what we saw was that those with bad diabetes climbed into the hospital faster than those with good diabetic results. That is, those who achieved a hemoglobin A1C of 7 or less came into the hospital at a lower rate than those with high hemoglobin A1C. And it was highly statistically significant. Just to remind you, on the x-axis are the number of days from achieving good or bad outcome of hemoglobin A1C, and on the y-axis is the cumulative percent who have been hospitalized at least once by day 100, 150, 200. And as you can see, that at 365 days, the people who achieved a bad diabetic result, 23% of them were hospitalized, compared to those who achieved a good result, of whom only 15% were hospitalized. But some of you who actually built your cohorts saw this graph instead. In fact, what you saw were people with good and bad diabetes outcome, no difference at all, and not statistically significant. Why was that? What did you do wrong in your cohort that caused this to happen? And what about this zone here? There's something very strange here where the good control people seem to be doing worse than the bad control people. That is, the good control people, at least in the beginning, are climbing into the hospital faster than the bad control people. Let's take a look and see what you did wrong with your cohorts. So this is what your cohort should have looked like. Remember, we were looking at a group of people who had initially had a bad hemoglobin A1C. The hemoglobin A1C was 9.5 or greater in June of 02 to 03 for people who were aged 21 to 64. And they had a follow-up hemoglobin A1C of good control 180 to 365 days later. And our index event line was pointing at the follow-up hemoglobin A1C line. That is, the index date was being taken at the time of the good control. So in this event canvas and in this cohort, we've identified a group of diabetics who started out badly, got under good control, and we've set the index date as the date from the good control so that any subsequent analysis will pick up what has happened after the good control. We are measuring the time to outcome from the repeat hemoglobin A1C, that is line 2, going forward 365 days. So now take a look at this cohort. What is this cohort doing? Well, this cohort, again, has the original hemoglobin A1C greater than 9.5, and it has the follow-up in good control, but its index event line is pointing at the first line. So what it would be measuring, if you took this cohort and brought it to a study designer, it would measure elapsed time from the original date of diagnosis of hemoglobin A1C in the bad range. To really highlight this, we highlighted the image here, and you can see what this is basically doing is it's saying, I want to find all the diabetics who started out badly, ultimately got under good control, but I want to follow them from the moment of their original diagnosis forward in time. That is, not from the moment they were brought under control, but from the moment of their first diagnosis going forward. For those of you who saw this graph as a result of the class exercise, you actually were not following people from the moment of their good or bad control, but you were following those people from their original diagnosis of diabetes, some who were ultimately fated to be in good control, and some who were ultimately fated to be in bad control. And you looked at the first year of their experience from the moment of diagnosis, even before they had achieved their target outcome, even before they had achieved the target diabetes control goal. And when you did that, you found that the good and bad control people had a hospitalization rate in the first year after their original diagnosis that was indistinguishable. The p-value was 0.5. But wait, there's something odd here. Even though overall it's indistinguishable, there seems to be something going on in this earlier period. There seems to be a separation of the good control and the bad control people, and what we're seeing is the good control people are climbing into the hospital faster than the bad control people in this narrow time window. In fact, if you focus your analysis in your study designer to look at 0 to 180 days after the initial hemoglobin A1C that defines someone as a bad diabetic, you'll actually highlight the distinction between the good control patients and the bad control people. Reminding you again, on the x-axis is the elapsed time from initial diagnosis of hemoglobin A1C, of the initial diagnosis of the patient as a bad diabetic, during the period when you're trying to bring about good control. And on the y-axis, we're calculating the percentage of patients who were hospitalized at least once. And what we are seeing here is that those who are ultimately fated to be under good control actually end up being hospitalized in the first 6 months at a higher rate than those who ultimately do not achieve the good control, with a p-value that's very significant. Now, why do you think that is? Why do you think that as we're getting people under better control, they actually have a higher hospitalization rate at first? Well, you can think it through. It could be that people are being aggressively treated with insulin and other drugs, causing hypoglycemia. That's causing their sugars to drop, and that's causing them to be hospitalized. Ultimately, they may be brought under good control, and then they have a lower hospitalization rate. But in the beginning, during that early management phase, they seem to be coming in at a faster rate. So it's absolutely critical that you identify on the index event line exactly which condition line you're going to be pointing to, because it's determining what question you're asking. You're asking two very different questions. So your choice of index date controls your question in the time to outcome method. Choose wisely. For additional insights in intuitive analytic work in healthcare, read Riddles in Accountable Healthcare by Eran Bellin. Available on Amazon in either Kindle or paperback.